So first question, arithmetic sequence is shown, 20, 33, skip a few, 228, find the sum of all of these. So I have a choice when essentially I'm looking to find the series. Anytime we're finding the sum of a arithmetic sequence, that's the same as finding the series, which is a series, just adding them all up. I want to add up all these terms. I don't know how many terms there are, but I do know the first term and the last term. And so quite often we can label this first term, we usually go label U1. The last term, I don't know what term it is, so I'll call it UN, but I do know it's the last term here that's being added up. And so when we know the first and last term of a sequence or a series, to find the sum of them, this tends to be the most helpful, so I'll start with that. However, we don't know how many terms we're adding up. We don't know n. And so at this point, most of our work, and there's not a lot of work left, but most of our work is to find out how many terms are we adding up. And we would have done similar things in the last lesson. And so for that, it's probably useful for me to come back to this basic general form of any arithmetic sequence. And I know the last term, or the nth term, is 228. I know the first term is 20. I do not know the common difference, but I do know, I do not know the number of terms, but I do know the common difference, which I can see from here, is 13. And so quite quickly I can solve this algebraically. And so we fairly quickly get to, if I write it down properly, we fairly quickly get to n equals 17. So there's 17 terms here. And now, clearly, I can just substitute that back into here, and I'll be done quite shortly. So the total sum, I now know there's 17 terms being added up. And I know the first term all along is 20 plus 228. Do the arithmetic, and you get 2,108. All right, for this question, a supermarket display of boxes is arranged in a pyramid shape similar but not identical to what you see in the diagram. The base of the pyramid has 28 boxes, and the top has just 8. So there's 28 boxes in total here. Again, it's in the same pattern, but this is not the exact image, and there's only one box in the top. So how many are there altogether? So if I was to write this as a sequence or a series, I could write this as the first term I can imagine being 28, plus there's 3 fewer in every row. So the next row clearly has 25 plus 22, and so on, all the way down to the final row. The top row, whatever, has just 1. And so now this question is almost identical to the last one. I know the first and last terms, I just don't know how many terms I'm adding up. So let me find out how many terms there are. And in this case, if I set it up like this, then my first term, if I go back to this formula, the first term I'm calling 28. The last term, the nth term, is 1, because again, if we call this is first term, second term, third term, I don't know how many I skipped, so that's the nth term. And so I can now solve for n. The common difference is -3, because there's 3 fewer boxes in each. Don't want to miss that negative. And so now fairly quickly I can solve again for n, just like in the previous question. And so I can see there are 10 terms here. Now, keep in mind, it's really easy to make a mistake with a negative here because the common difference was negative. It's easy to miss that either somewhere or forget to distribute a negative. The good thing is if we make that mistake, my answer would almost certainly I'd get a negative number of terms, which doesn't make sense. It's not valid when we're dealing with sequences. We don't have negative terms. And so usually we can quite often catch our mistakes. But there's 10 terms here, which means there's 10 rows. And so if I go back to this, and so quite simply, I can do the arithmetic, and I get 145 in total, or in this case, 145 boxes. So for the last question, we have some data representing the number of eggs in a carton, as well as the overall mass in grams of that carton. And we want to use what we've learned to try the best we can determine the mass of a full carton of eggs. And we'll say a full carton is a dozen. So one thing to do is, I can see this as a arithmetic sequence or a series if I want, in which my first term is 95, my second term is 156, and so on. And so it's natural we probably want to find the common difference. However, what we'll see is that, not surprisingly, because this is meant to represent real data, is that it's not the exact same number every time. For example, the common difference, so the difference from 95 to 156 is 61. From 156 to 220 is 64. And if I do that for all of these, we'll see we don't get the exact same number every time, which again is what to be expected. These are representing each time I add an extra egg to the carton, and eggs are not a standard exact size, but they should be similar, and they are similar. So I have a few options. One thing I could do is just find the average of all of these, add them all up, divide by, in this case, 5 to find the common difference. Or it's the same idea, I can kind of speed it up and just go straight from the first to the last and realize to go from 95 to 395, I'm going up by 300 grams. And that's from a difference of adding 5 more eggs. So you may want to think that's 6 eggs, but keep in mind, again, I'm starting at 95, so it's taking 1, 2, 3, 4, 5 more steps, 5 more eggs from 1 to 6. So if I divide by 5, that gives me the average as well. It's the exact same thing as just adding up all these values up here and dividing by 5, finding the average. And so I get a nice clean 60, which means each egg weighs approximately 60 grams. And for the purpose of this question, I'm going to say, as best we can, each egg is 60 grams. And so now if I want to find the mass of a dozen carton of eggs, I have several options. One option is just to use this formula here, our basic arithmetic sequence formula. Because if I set it up like this, then I'm imagining this being the first term, 95, like I've stated. And if I want to find a full carton of eggs, then I want to imagine this here being 12 terms. I want to find U12. I want to find the 12th term. And a perfectly great way to do it. And so I'll finish it off, then I'll mention one other approach. But at this point, I have everything I need. So the first term is 95. The common difference, I don't know that yet. The number of terms is 12 minus 1. The common difference is 60. Do the arithmetic here, and you get 755 grams, which is our best estimate of what a full carton of eggs would weigh, or its mass. Another option, once we knew each egg was approximately 60 grams, we could have just used that to find the mass of the actual carton when it's empty, which is quite simple to do. Take that 60 and subtract it from 95, and so we would get 35. And so we would see that the carton of eggs, just empty, the empty carton weighs 35 grams. And from there on in, it's simple arithmetic. It's going to be 35 plus 12 times 60. And if you went 35, the mass of the carton of eggs, plus 12 of these 60-gram eggs, you'd get the exact same number. So I'm not going to bother doing it.